Hello everyone, welcome to Happy Learning Tutorial. So today we are gonna learn few more functions in continuation with the use case demo for Athelete data analysis using PySpark in GCP notebooks. Okay, so I'm here using the Google Colab notebook for my analysis and for creating my datasets, data frames, tables, views, and other objects using the medallion architecture in bronze, silver, and gold layer specifically. So today we are gonna analyze another table, which is the customer sample table. Again, for your storage, you must save and load your data into your permanent storages, whether it is your drives or whether it is GCP bucket or S3 or Azure data factory. Okay, as per your use case and analysis. For me, I just need it for this session demo, so I have just stored it in the session storage space, which is here as customer sample CSV, right? You can see yes. So now first step which we need to do every time is to import the packages. So what is the first step? First step is always to import necessary packages. So I have imported the necessary packages, which are PySpark packages. So first is pip install PySpark from PySpark.sql.functions, import star, import numpy, which is your numerical library, as np, import pandas, which is useful for reading your data and used for creating plots and graphs. Then again, and converting your data from Spark data frames to your pandas data frame. And then we are using the matplotlib.pyplot as PLT, which is again your graphical libraries, which is very useful and beneficial for creating graphs and visualizations for your analysis or for your references. Next, we are going to use one more library, which is Seaborn library again, which is going to help us to create visual plots. Okay, so after importing all the libraries, I'm importing the configurations of the operating systems. For you, if you're aware or not, the Spark clusters are always running on Java on the backend. So if you are aware, it's the multi-threaded architecture, and parallel processing always happens with RDD, that is resilient distributed datasets. So Spark clusters always work on the Java, so you should always install your Java OpenJDK libraries as per your OS configurations. Next is to import the PySpark. So from PySpark.sql import Spark session. In order to initiate the Spark session, we always have to import this library first. That you have to create a Spark session for with the Spark variable initiation, wherein through that we can further use the Spark functions and further utilize the and create the data frames using the Spark processing engine, Apache Spark processing engine. Okay, so here I am using from PySpark.sql import Spark session, creating a Spark variable to initiate my Spark session as Spark session.builder, and then the app name, that is I'm giving it as Athelete Data Insights Demo by Ankita, and then the config is Spark UI, and then port, and then you have to give this get and create. Most of the time you get this error over here. Sometimes it does not allow you to give the parenthesis over here, and if you don't give the parenthesis over here, it will not allow you to save your tables. I did this mistake, but it just due to you have to set your JVM virtual environment. Okay, it will help you to further resolve your errors. Like I did a couple of hit and trials and it worked. Okay, so you have to read a little about you should have the basic information, like you should have a basic understanding how it works. Then only you will be able to figure it out and resolve it quickly. Okay, now the first step is to create a bronze data frame. So I'm creating a customer bronze data frame. First of all, I want to read the data frame into the bronze, like my raw data. I don't want to touch this file at all. I just want to extract the information from this file. I just want to read the file. I just want it on my system and load it as it is. So we are going to perform extraction, transformation, loading, and we are performing extraction, loading, and transformation. So I'm extracting and loading the data first, and then applying the transformations, and then further creating the visualizations using my gold layer. So my bronze layer is just like acting like a data lake, right? Or you can say a raw layer where I'm not touching my file at all. I'm just trying to read that file. So as you know, how can we read that? Using the pandas library. So customer df underscore bronze pd.read csv, give the path of your csv wherever it is, whether it is on S3, whether it is on GCP bucket, or whether it is on Azure, Microsoft Azure. Okay, so as per your cloud convenience, as per your cloud environment and your convenience, you can do that. Next is I want to see the data inside this file. So in this data frame, I can use customer df underscore bronze dot head, and you can specify, the number of columns you want. So here it is giving me the entire details of all the columns over here. Like we have activity name, effective date, step count, distance covered, calories count, expected coins, and actual coins to be added. So this is all the data we have over here. Next is Spark df. So here I want to convert this normal data frame to a Spark data frame. Okay, why do I want to do that? Because I want to use and apply the SQL logics over here. I want to convert it to an object as a table and a view. So in order to do that, first of all, I have to convert it to a Spark data frame. So for Spark data frame, spark.create data frame. How can we create the data frame in Spark? Using this syntax, spark.create data frame, and storing it somewhere into this variable, which is Spark df. Okay, so which data frame? Which we have already created above, that is customer df bronze, I should say, right, which we have created. And then I want to save it as a table, which name is customer bronze, and mode is override. Since this is the existing table, so you have to explicitly specify mode.override. Otherwise, if you're creating it for the first time, you don't need to write this option, which is mode override. Okay, it will be the first time. You just need to write it till here. Next, so once you have created a table, now you can use the Spark SQL functions to query your data using your SQL statements. Like I'm going to use spark.sql select star from customer bronze. This is my new table in the bronze schema, order by customer ID. So I just want to have a look at the data, so I have to use the show command, and this helps me to see my entire data set, okay, which is present, and storing it as a table. So this is now in a row based and column based format, which is in a form of a table, which we usually call as a table in SQL. So this is called as what? Tabular format. Now next is I want to apply certain transformations. So where I'm going to find the average of step counts, total step counts, average of distance covered, and average of total calories burnt or calories count in this table for each month. So the data is collated for each day, or you can say each date of the month, and we are going to create a view or a kind of a data frame where I am going to apply the transformation to churn the average, to apply some calculation logic to find the average of at least 3 columns. So what I'm doing over here, I'm creating a data frame which is in my silver schema, average over each month df silver, where we are using spark.silver, select customer ID. I want to extract the year. So year from where? From the column effective date. I'm extracting year. Then the month, I can explicitly specify the name as year. Then I'm extracting the month from again the same column, which is effective date, as month. Again we can specify this as date as month, and you can also similarly you can extract the date if you need it. I don't need it. I want the data to be collated and grouped over grouped as average over a month. Okay, so average step count, average of distance covered, and average of calories count. So when we simply queried this data, okay, from where? From customer bronze table, group by customer ID, the first column and the second column, which is not a aggregated column, right? So when I did this, okay, what I get, we got to see the result like this. So average step count, it was able to do that, because the data was very simple. If you see it here in the step count, the data was something like this. So we had only numerical values in step count. So it was easy for PySpark engine to perform the perform this SQL operation of average, finding the average of this column. But then for this column and this column, we got certain null values, which is not the case, right? Which is not required. We don't need this result. Okay. So after this analysis, what we did and why this was coming null, the reason being, we have a unit of the distance attached with it, that is kilometer and calories attached. So we have to somehow segregate the numerical value from the units, and then need to apply the calculation logic, which is finding the averages, right? So in order to do that, how can we do that? So in order to do that, what we have to do is we have to explicitly segregate the numerical value and the unit value. So how can I do that? I'm using it spark.sql, select customer ID, substring distance covered, and I'm applying the substring operation to get my numerical values and then the actual value. So I'm comparing it, okay, whether we are getting it for all or not. So I've checked for entire data. Here I'm just displaying 10 rows for your reference. Now once you have done that, okay, now you have to apply the average on this column which you have segregated. Okay, so this is how we have to perform the analysis. So in my silver layer, during performing the analysis, we have to do this. Now for doing this, again the value was coming, can you see the average step count is coming somewhere up to 10 decimal places, which we don't need, right? We just need the average max up to 2, 3, 4 or 5 decimal places. So again, you have to apply another logic and the calculation operation, which is round. So here what we are doing is, I'm trying to store the average information of step counts, distance covered and calories count into a data frame inside my silver layer, that is average step over each month df silver, as spark.sql, select customer ID, month from the effective date, extracting the month because I just need the month right now. Okay, I don't want to know, I know the year, so I can just write it as month, average of step count as average step count, then from customer. So I'm extracting each value for now. So if you run this, we get to see the month 1, 2, 3, that is the January, February and March, the data is collated, and the customer ID, since we are specifying it over here, right? If you do not specify this, or you somehow comment this out, then you will have it for your entire set of participants, okay, whatever data is there in your table. Again, for spark.sql, select customer. Okay, now what I'm doing, I'm trying to trying to extract the units apart from the numerical value. So this is some hit and trial using the regex. Also you can do that. So it worked, the simple substring worked, so we should use this one instead of going into the complex regex expressions. So now what I am doing is, I'm trying to find the average distance covered over each month silver. So this is all for my analysis, and I've saved them as separate columns. Why? I've saved them as separate data sets and columns in case in near future, if the value is not what is present over here, that is 2 decimal places, the 2 digits before decimal or 3 digits before decimal, then we have to somehow work it over here in our calculation logic. So that's why I'm saving it separately also, so that whenever we face some new value in near future, we can always go back here and make it work and operational to fix this value, and it will automatically reflect in our data frame and the data sets and the tables. So here again, counting the calories in the similar manner, I have applied the round function, average function, and then the substring operation. So first, how it will start, it will first apply the substring, then it will apply the average, and then it will round it off to the 5 decimal places, which I have written it over here. Okay, so for the calories count also, we have extracted the numerical value apart from the unit, which is CAL, okay, which was written there. In the similar manner, select customer ID, then round, average, and substring of calories count column 0, 2. Why? Because I want to start it from the first digit, or you can say the first element, and till 2 elements. I want to extract till the last value as 2 elements, next 2 elements, and then it will stop. Okay, then the third element was CAL, which is your unit, which we don't need. And similar was the case for distance. Like here I showed you 0, 4. So 0 is the first element and 4th is the last element. So we stopped at 4 because after fourth element there was there was the unit, which was kilometers. So this is for distance and this is for calories. Okay, this is done. Once this is done, group by the first column having customer ID and this. Now once this is done, we can also concatenate all these three data frames which we have created using pandas, and then what I'm doing is I'm trying to store it in a silver data frame. Okay, so I'm combining after doing the analysis, I'm combining the entire average calculations so that I can create a view from this data frame. Okay, so average over each month data frame silver is equal to spark.sql, the syntax. Now you can apply your SQL query inside this. So SQL query is select customer ID, simple like we do that always. Year from effective date as year, month from effective date as month, round, average step count. I want to round the step counts to 5 as average, and then round average cast in substring distance covered as double. I'm also casting this as double up to 5 decimal places. Again, similar for the calories count, up to 5 decimal places. From customer, group by the first column, the second column, that is the non-aggregated column, and the third column, and leaving the aggregated columns, and then order by what? Order by customer ID. So here I have not applied, if you see, I have not applied the filter, I have not applied the having clause. So it will give me the data for entire participants. So there are 2 participants here, we can see, and the data is collated for 2 months, that is 3 months, which is January, February and March. So the month is there, year is there, average step counts up to 5 decimal places, distance again up to 5 decimal places, sorry, yeah, whatever is the value, up to 5 decimal places here you can see, and then the calories count. Now I want to save this into a temporary view. How can I do that? Spark df, okay, Spark df dot create or replace temp view. This is the syntax. You cannot play with this. You have to remember this syntax, then only you will be able to create. If you ever miss this syntax, you will not be able to create a view. Even if you forgot to write or replace, it will give you errors. Okay, make sure you remember the basic syntaxes. Customer temp view gold. Now I want to create this as a gold view, okay, in the gold layer, and I want to use this further. So average over each month silver, pd.concat. Okay, this we already did earlier. Okay, after creating the gold view, I want to see the data inside this view using the SQL query. How can I do that? Spark.sql, select star from customer temp view gold and show. So this is how your view looks like. Okay, and this is the customer table. Now we are creating this is the data set, average over each month data frame silver, and if you see, this is the silver one. Okay, I want to see the gold one. Average over each month data frame silver. Okay, I am storing it in a variable first, spark data, and then I want to see whether it is having the same schema or not. I want to check all the details. Now I am creating the gold view. So once we have created the gold view, I can run this query, spark.sql, select star from average. Okay, that was a silver view we created. I gave it a wrong name there. That was a silver view. First we created a silver view, and then we created a gold view. Yeah, I think I gave a wrong name there. This is a silver view. Okay, and this table is customer temp silver. Okay, yeah, the actual table and the created view. Okay, both are there now. Right, next is spark.silver, spark.gold, spark.sql, select star from average over each month and gold, and this is how your final table looks like. And in this table, what I am doing is I'm trying to save it as a view as well as a table. So spark underscore data, which is my variable, dot write, that is the operation we want to perform for saving it as a table. So you make sure you remember the syntax, save as table, A capital, T capital, otherwise you will get errors like me. I was getting simple, silly errors, silly syntax errors, and you have to just make sure you are writing the exact syntax, not even a spelling mistake or not even a uppercase or lowercase is handled properly. Make sure all this is handled properly. Average over each month, which will come of course with practice. As long as you do a lot of things, it automatically comes into your practice. So now this is a gold layer, and now I've created this table. Since I've created it twice, so I have to write the mode as overwrite. If you want to append or insert anything, you can do that as well. If it is a first table, you're creating it for the first time, you don't need to give any mode, you do not need to define this. If you are performing any operation on the existing table, you are merging it or updating it or inserting or appending anything, you have to specify your mode. Okay, next is spark.sql select star from average each month. This is your table which is created, and now I want to visualize this. So how can I do that? So first you have to convert your Spark data frame to a pandas data frame. How can we do that? So this is my Spark data frame, right, originally, which we created, if you remember, average over each month, right? And now from this data frame you have to do what? Convert it to pandas. So average over each month underscore data frame to pandas. Now once this is converted to pandas, so now pandas will help me to do what? To plot this using the matplotlib and Seaborn library, right? So plot plt matplotlib.pyplot.figure. Okay, what is the figure? What size you want? 12 by 6. This you can specify as per your requirements. Or then I want a bar graph using Seaborn, so I'm using sns.barplot. You can use line plot, you can use grid or gradient, whatever you want. I want a bar plot. So data, in the data field, what do you want to see? I want to see the first thing, average over each month underscore df, and in the x range you have to define your column. Which column do you want to see? I want to see over the month. And in the y column, what do you want to see? I want to see average step counts. Okay, and the label is average step count. Similarly for, okay, so you can see it here, this is the average step count, the label which is coming, and it is showing me for the first month the total step count is somewhere close to 5. Okay, 5 something. Okay, in between 6,000 and 7,000. So it was something in between 65 something. Okay, 66, 7, 8, 9, whatever. Next is, you can also give the values over here. It's up to us how much coding you want to do. Now SNS gradient plot, again here I'm using the same data frame. Again for the x I'm giving the value as effective date, I'm extracting the month of the effective date, and for the y, average distance covered. Instead of average step count, this time I'm using distance covered for average distance covered, and similarly for calories count, I'm using sns.lineplot data average over each month from this data frame. Again in the x bar I'm extracting the month from the effective date, and in the y column I'm plotting the average calories count and labeling it as average calories count. Now what title do you want to give to your graph? So you can give plot.title average metrics over each month. X label would be month, Y label would be average value. X text you can give the range 1 to 13 or 1 to 15, let's say. Okay, and then Y legend, plot that gradient true and show. So this is how it looks like, right? You can see this is for a month, first, second and third. This is your average step count, and you can give it here as bar. So if you run this, here you get to see. Alright, hope you like this analysis on PySpark engine, and it would have, and you learn something new, it would have helped you to perform the analysis in an easier and efficient manner. And if you like this, please do like, subscribe, share and connect with me for more such videos. Have a nice day. See you later. Bye bye.